Welcome to the Walton Pi. Today we're going to talk about the derivative function. So the derivative of a function has a lot of applications where we might want to know it at multiple points. So finding a function and then plugging in the points we need is a lot more efficient than finding the derivative at each different point. So for example, the derivative of position is velocity, and that's something useful to know at any given time, especially if you're a cop trying to see someone speeding, or if you're the person trying to not get caught speeding. It's important to know what your velocity is on the road, and so we need to be able to know what's the derivative of a position function at any given time. So we need to be able to have a derivative function. So the definition of the derivative function, we're going to want the function to be in terms of x, or in terms of whatever our variable is. So we can modify the equation for the derivative at a point to make it be in terms of x rather than in terms of the point a. So we are going to define the derivative of f at x to be equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. We're going to call this function the derivative of f. So find the derivative of f of x equals x squared minus 13x plus 3. So if we just use the definition that we just had, f prime of x, or the derivative of f, is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Plugging in x plus h into our equation, we get this fairly large looking fraction, which when we expand it out, we are going to be able to see that a lot of the terms are going to cancel. The x squared and the minus x squared cancel, the minus 13x, the plus 13x, and the plus 5 and minus 5. All of those cancel, and we're left only with terms that have an h on the top. We can then divide an h through from everything, so we get the limit as h goes to 0 of 2x plus h minus 13, which is just going to be 2x minus 13. This is the derivative of x squared minus 13x plus 5. That tells us that if we want to find the slope of f of x at x equals 6, we can just plug in 6 into the derivative of f, and we get 2 times 6 minus 13, which is minus 1. So at x equals 6, the slope is minus 1. Let's do another one. Let's find the derivative of the square root of x. Well, again, we're just going to plug this into our equation, so we get the limit as h goes to 0 of the square root of x plus h minus the square root of x all over h. Anytime you're dealing with square roots and addition in either the numerator or the denominator, if you're trying to cancel, a good rule of thumb is to try multiplying by the conjugate. So that is where we multiply the top and bottom by the exact same thing, except we replace the addition that connects the two square roots with a subtraction, or a subtraction with addition. So here we are going to multiply the top and bottom by the square root of x plus h plus the square root of x. And that's going to give us on the top the square root of x plus h squared minus the square root of x squared, which gives us x plus h minus x, so that's just an h, all over h times the square root of x plus h plus the square root of x, which is the same thing as the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x, which when h is 0 is just 1 over 2 times the square root of x. And so that is the derivative of the square root of x. I hope this video was helpful. Please like and subscribe if you haven't already, and please check out some of my other videos. I hope you have a great rest of your day, and good luck with the rest of your math.